In this lesson, we'll learn about the Sheen component of the standard surface shader and how to create realistic fabric shaders in Arnold for Cinema 4D using the Sheen component. If you take a look at this reference photo, you can start to see what makes fabrics look like fabrics. Look how the faces or polygons that are parallel to our viewing direction are darker, and the perpendicular faces to our viewing direction become fuzzier and brighter. If you can simulate this, you can get realistic fabric shaders, and this is what Sheen component is supposed to do. Sheen basically simulating microfibers and cloth-like surfaces or any sort of fuzziness on a face, on fruits, and so on. Before creating any actual fabric shaders, let's take a look at the few parameters in the Sheen section. For a realistic fabric shader, you only need the base and the Sheen component plus any bump, normal, or displacement mapping. So for now, we can zero out the specular weight, set the base weight to 1, and use a dark gray with the RGB values of around 50. In the Sheen component, let's set the Sheen amount to something like 0.5, and the Sheen color is set to white. We immediately get that fuzziness at glancing angles. You notice how the parallel faces to our viewing direction are showing the defined darker base color, and the perpendicular faces are showing the defined white Sheen color. In addition to that white color, Sheen component also adds that feeling of fuzziness and cloth by simulating microfibers. We have the Sheen color that controls the color of the microfibers, and generally this should be a brighter, less saturated version of the defined base color. For now, let's keep it at white. We also have this Sheen roughness, which modulates how much the microfibers diverge from the surface normal direction. Basically, using the roughness value, you can control where that fuzziness begins. By increasing it, it begins at lower angles from the parallel faces, and by decreasing it, the fuzziness starts at higher angles from the parallel faces. If I set the roughness to 0.1, you see how the Sheen effect is limited to very extreme glancing angles. And if I increase it and set it to something like 0.6, now that Sheen effect is more widespread and starts earlier. So that's about the Sheen component. Now let's make some realistic fabric shaders. First, we try to create a purple velvet shader. So create a new standard surface shader and assign it to the geometry, and open up its network. As always, zero out the specular weight. Set the base weight to 1. For the base color, use this dark purple. So basically, the base color is going to be a dark version of the color that you have chosen, and the Sheen color would be a brighter, less saturated version of that color. You notice it doesn't look like fabric at all because we still don't have that previously described attributes of fabrics. For something like velvet, set the Sheen weight to 1 and Sheen roughness to 0.1, 0.2. You can experiment with these parameters. And for the Sheen color, let's use a brighter, less saturated color compared to our base color. And now, as you can see, we get this nice velvet shader. Let's go for a blue velvet. I'm gonna just copy the purple velvet shader and assign it to the geometry and open it up. To create a blue velvet, you just need to obviously adjust the base color and the Sheen color to a dark blue and a less saturated, brighter color like a pale blue. And now you would have a nice blue velvet shader. If we bring up the reference picture again and zoom in a tad, you notice we have this kind of fabric pattern throughout. So let's add this pattern as well. I'm going to duplicate the purple velvet shader and assign the new shader to geometry. Now open it up and load this fabric pattern image. And we want to use this as the bump map. So connect it to the bump map input of a bump 2D node. And connect the bump 2D node to the normal input. And as it is velvet and that pattern is not that visible, set the bump height to something low like 0.2 centimeters. If we connect the fabric pattern image to the beauty port, you notice it doesn't sit quite well on the geometry. So let's set the tiling of the fabric pattern image to 0.2 and 0.2. Now it looks better. Now connect the standard surface to the beauty port again and let's see what we get. And now we have this beautiful fabric pattern as well. Now let's create a crushed velvet, something like this photo right here. For this, let's duplicate the original velvet shader and open up its network editor. We need to have two base velvet shaders. One should be fairly brighter than the other one. Then we mix the two to get the final crushed velvet look. Let's duplicate the standard surface shader again. Now let's use a brighter base and sheen colors compared to our base shader. Now add an Arnold layer shader and connect it to the beauty port. Layer shader basically allows you to stack up and mix shaders. Connect the darker velvet shader to input 1 and connect the second velvet shader, the brighter one, to input 2. Now to mix the two, load this map called BW8, this black and white map. And use it as the layer 2 mix input. If we set the BW8 as the beauty shader, we can set its styling to something like 0.2 just to get a better result. Now connect back the standard shader and let's see what we get. And now we are getting this nice and realistic crushed velvet shader. Next, let's create a simple upholstery cotton fabric shader. So let's create a new Arnold standard surface shader and assign it. And zero out the specular weight. Load this fabric pattern image again, and obviously you can find your own fabric pattern images online. There are tons of them, and use them instead to get different patterns and different looks. I'm going to set its styling to 0.2. As this is going to be used as our base color, we can set its color space to something like utility sRGB texture and connect it to the base color and set the base weight to 1. We want to use the same image for the sheen color as well, but we want it to be brighter compared to the base color texture. So connect the map to an Arnold color correct node. Now connect the color correct node to the sheen color input of the standard surface shader. I'm going to increase the gamma to 3 in the color correct node so we get a quite brighter version of our original texture. Now we need to connect the color correct node to the sheen color input of the standard surface shader. Now set the sheen weight to something like 0.6 and the sheen roughness to something like 0.3. For the bump map, connect the original fabric pattern image to a bump map input of a bump 2D node. Set the bump height to 1 or even 2 centimeters because we want the pattern to be quite obvious, and connect the bump 2D node to the normal input. And here is our beautiful realistic cotton. While we are here, let's create a colored version of this. Simply duplicate the whole shader and assign it. Add a layer RGBA node, which allows you to layer up textures and RGBA inputs. Use the fabric pattern image as input 1 and use this light reddish brown as the layer 2 color. And set the second layer operation to negation and connect the layer RGBA to the base color input. And simply use the same layer RGBA node as the input for the color correct node that is connected to the sheen color. For this to look better, let's increase the sheen weight to something like 0.8. So it really depends on what you are looking for. If you want more of that fuzzy feeling, just increase the sheen weight. Let's see what we get. And here we have it. From now on, you can skip the rest of the lesson as we'll be creating just a bit more complex fabric shaders. So skip the rest of the video if you wanted to, or if you're curious, just keep watching. Next, let's go for a satin look. And for this one, we won't be utilizing the sheen component. As for satin, if you take a look at this reference photo, you notice satin is different and the highlights are kind of playing with you. There is no well-defined pattern that you can describe, but I have pretty good formula to create highly realistic satin or silk shaders, and it involves curves. Let's create a new standard surface shader. Zero out the specular weight and assign it to the fabric geometry. For silk, first we need a facing ratio node. Let's load it and connect it to our base color. Facing ratio outputs 0 or black for the perpendicular faces to our viewing direction and 1 or white for the parallel faces to our viewing direction. But we want to be able to remap these values. For this, we can use a ramp float node. So connect the facing ratio node to the input port of the ramp float and connect the ramp float to the base color input of the standard surface shader. Now using this curve, we can remap these values to whatever we want. There is a particular curve that results in a very, very close look to satin or silk. Now let's open the curve in a separate window. We are trying to put the highest and brightest values to be a bit off of the exact parallel angles to our viewing direction. Making the very frontal angles a bit brighter at something like 0.1 or 0.2. And a curve like this should give us a silk-like look. Just maybe it needs a bit more work to make it better. I have saved out a better version of this curve. Let me paste it here. This should give us a really nice satin shader, as you can see. The next thing would be to incorporate the specific colors that we are looking for. To do that, we can use a mix RGBA shader. And connect the ramp flow to the mix input of the mix RGBA node. For the input 1 color, let's use the dark purple, and for the input 2 color, use this brighter shade of the same color. So that's the same formula, a darker shade and a brighter shade of the same color. And voila, you have a very realistic satin shader. To get a different satin color, you can simply change the input 1 and 2 colors. First, duplicate the satin shader and assign it. And let's use these dark and bright green colors. And here is our green satin shader. Now let's go for a towel shader. I'm gonna create a new standard surface shader and assign it. Zero out the specular weight as always and open up the base and the sheen components. Use this darker shade of blue as the base color and set the base weight to 1. And this brighter shade of the same color as the sheen color and set the sheen weight to around 1. We already have this Arnold parameters tag applied to the fabric geometry. Let's go to the subdivision section and increase the iteration to about 4. We need more geometrical detail for the displacement mapping. We talk about displacement mapping later on in this section. For the displacement map, let's load this towel image. See, it's a black and white version of a kind of rough towel. And set its styling to something like 0.6 and connect it to the displacement input of a displacement shader. And set the, obviously connect the displacement shader to the displacement port of the standard surface shader and set the displacement scale to something like 0.006. Now let's see what we get. And here is our towel shader. So that's about the sheen component of the standard surface shader and creating realistic fabric shaders in Arnold for Cinema 4D. So I will see you in the next video.